Now see here, rise of liquid in capillary tube. So actually we are going to derive formula for the height through which liquid rises in capillary tube, and this formula is also known as ascent formula. And now see here, in this beaker I have taken here the water is here, and now when a capillary tube is put into this, the surface of water is like this, that is a concave surface. Now there are 2 points A and B. B is inside the convex side and A is on the concave side. At A there is a excess pressure. So pressure at B is here P minus 2S upon R, where P is atmospheric pressure and now R is the radius of liquid meniscus, which I have shown here. So R is the radius of liquid meniscus. Now, but if you see the point C and D, the surface is plane over here. So pressure at C and pressure at D both are equal, that is equal to atmospheric pressure. But now see, according to Pascal's law, pressure at B and pressure at D should be equal because they are in the same horizontal level. But the pressure is not equal here. At B it is P minus 2S upon R, and at D it is a atmospheric pressure equal to P here. P is, I have taken here atmospheric pressure. So you can write here P atmospheric is equal to P here. Now due to this pressure difference, liquid rises in the tube to the height h, and it rises till the pressure at point E will become equal to pressure at D. So when the liquid rises in the tube through a height h, then the pressure at E is equal to, you can write here, pressure at B, that is P minus 2S upon R plus H rho G, because H is the height of the liquid, rho is the density of the liquid, and G is acceleration due to gravity. So now the pressure at E is equal to P minus 2S upon R plus H rho G. Now the pressure at D is equal to, that is pressure, atmospheric pressure. In equilibrium these two pressures should be equal. So you can write here now the P is equal to P minus 2S upon R plus H rho G. Now this P and this P will get cancelled. You will be getting H rho G is equal to 2S upon R. And now you have to get the formula for H. So we can write here H is equal to 2S upon R rho G. So this formula is H for the H, that is called ascent formula. It is for the height by which the liquid rises in the tube. Now we can also convert this capital R into the radius of the tube. Suppose the radius of tube is, this is small r, capital R is the radius of the the liquid meniscus. Theta is the angle of contact, so this theta and this theta. So we can write here cos theta is equal to R by R. So R is equal to R upon cos theta. Now so this same formula will become now here, this one ascent formula which is here, that is equal to H is equal to 2S cos theta upon R rho G, and this is called here ascent formula. So this is the ascent formula in terms of the radius of the liquid meniscus. This is the ascent formula in terms of the radius of the capillary tube and the angle of contact. If in place of this tube, this liquid water, if you are putting the tube into the mercury, the level of the liquid will fall down, and in that case this formula will be known as descent formula, and we can use sign negative for that. Now we have done the formula for the rise of the liquid in a capillary tube, and that is suppose this height h, and that is called ascent formula, and we have done h is equal to 2s upon r rho g, where this capital R is the radius of liquid meniscus. Now suppose if the rise of the liquid in the tube is more than the height of the length of the tube, it means h is more than the length of the tube. what will happen? Will the liquid overflow? See here, in this case liquid will not overflow. This can be explained by this way. R you take this side, HR is equal to 2S upon rho g. Now see here, surface tension remains constant for the given liquid unless temperature changes or impurities are added. Density of the liquid also remains same. G acceleration due to gravity change remains same. So this quantity is constant. So we can write HR is equal to constant. It means H is proportional to R, 1 by R. Larger the radius of the meniscus, smaller the height. So if the length of the capillary tube is less than the height up to which the liquid rise, then the radius of the liquid meniscus will increase, but the liquid will not overflow.